All right, in section 6, what we're going to be doing is we're going to be bringing all these properties that we've learned about all these different quadrilaterals and trying to identify what specific type of quadrilateral we have based on given information. So what we want to do is we can make a table for ourselves that tells us which properties each shape has, and that'll help us. The other thing that's going to help you is your front page on your packet. Okay, because this is a flow chart, was what we have. So if I start with a quadrilateral and I start looking at what I have, if I see I've got two sets of adjacent sides, I can move over and say, okay, that's a kite. If I find out it's got four congruent sides, then I can move down and say, okay, it's a rhombus. Then I can test to see, does it have a right angle in there? That would make it a rectangle, which would make it a square. Things like that. So this is a good flow chart you can use. The other thing that we're going to use is this table that we're going to fill in right now. So we're going to put an X in the box if the shape always has the given property. So what shapes always have both pairs of opposite sides that are congruent? Well, parallelogram always has that, because that's one way to prove that something's a parallelogram. If a parallelogram has it, that means a rectangle and a rhombus and a square will also have it, because those are all specific types of parallelograms. Trapezoid does not always have both pairs of opposite sides that are congruent. A kite never does, because otherwise it would be a rhombus, not a kite. Which ones have diagonals that are congruent? Parallelogram, not always. Rectangle, always does. Rhombus, not always. Square, yes, because a square is a type of rectangle. Trapezoid, no. Sometimes it does. This is only isosceles. So you might want to make a note for that. If it's isosceles, yes, then it's always true. Kite, no. Diagonals that are perpendicular. Parallelogram, no, not always. Rectangle, no, not always. Rhombus, yes, always. Square, yes, because a square is a rhombus. Trapezoid, no. Kite, yes, always has perpendicular diagonals. Diagonals that bisect each other. Parallelogram, therefore, rectangle, rhombus, square. Diagonals that bisect one another, no and no. Consecutive angles are supplementary. Parallelogram does, which means all of these do. In a trapezoid, yes, but you have to be careful. The non-base angles will. So non-base angles will be supplementary because they're consecutive. Because remember, okay, if this is my trapezoid, right, these angles will be supplementary, but this one will not be supplementary with this one. Okay, so you've got a couple sets that are always in there, but it's not all the consecutive angles. And in a kite, no, not always. Both pairs of opposite angles are congruent. Parallelogram, yes. Therefore, rectangle, rhombus, and square. Opposite angles are congruent, not always. And one set for a kite. So both pairs, I guess both pairs, no. All right, determine the type of quadrilateral given. So let's say this is my picture, and that's what I have marked. What can I determine from this? Well, I can see that my diagonals are bisecting the angles. And I can also see that my opposite angles are congruent, okay, because these are two sets of double lines, two sets of double lines. So these both are the same, and these are the same. So since opposite angles are congruent, that gives me parallelogram. Okay, then I know that your diagonals are bisecting angles. So that gives me rhombus. That's as far as I can go. So this is a rhombus. they give you points, then we're back to using slopes and distance formula. So let's find the slopes first, because that's going to tell us the most information. Okay, so QR, I'm going to take 7 minus 5 and get 2. 4 minus 2, which is 2, I'm going to get 1. RS, I'll go this way. 7 minus 6, 1. 4 minus 8. Notice I'm always going the same way. If I'm taking 7 minus 6, I have to take 4 minus 8. So I get negative 1/4. Here I'm going to take 6 minus 1, I get 5. 8 minus 3 is 5, so I get 1. So I've got one set of parallel sides. Let's see if the last one is. So I'm going to take 5 minus 1, 4. 2 minus 3, negative 1. Okay, these are not parallel. So what I've got at this point, I've got one set of opposite sides that are parallel. So far I've got trapezoid. Now, if we look at my chart on the front, the only thing I can go from trapezoid is to isosceles trapezoid. So I need to see if I have congruent legs, congruent set of base angles, or congruent diagonals. So in order to do that, so let's do legs first. So if QR and ST are the bases, the legs would be RS and TQ. So the length of RS is going to be the square root of, we'll do this the long way, RS. Subtract the y's, I get 1 squared. Subtract my x's, I get negative 4 squared. So I get the square root of 17. Okay, the other leg would be TQ. I can already see I'm going to get the same thing, okay, because I'm going to have, this is the difference in x, this is the difference in y, so I'm still going to get the square root of 17. So I have congruent legs, so I could say isosceles trapezoid. I also could have checked the diagonals. Now the diagonals would be, if I went QS and RT, those would be diagonals, and I could see if those are congruent. So let's just check it just as an extra practice. So QS, the distance from Q to S. 6 minus 5 is 1. 8 minus 2 is 6. So 1 squared plus 6 squared. We're going to have 36 plus 1. I get the square root of 37. Let's do RT. 7 minus 1 is 6 squared plus 4 minus 1 is, oh, sorry. 7 minus 1 is 6. 4 minus 3 is 1. Excuse me. So I get 36 plus 1 again, square root of 37. So my diagonals would have been congruent too, and that would have also led me to isosceles trapezoid. So that's what this shape is. So those are things you're going to be doing. This is a big one, you know, using the slope and distance formula, those things that we learned very, very early in the year.